In Chapter 3 today, we're going to take a look at Section 8.3, which is the mole concept. So what is a mole? The number equal to the number of carbon atoms in 12.01 grams of carbon. That's what a mole is. The number equal to the number of carbon atoms in 12.01 grams of carbon. 1 mole of anything is 6.022 times 10 to the 23rd units of that thing. So I could have a mole of ducks, a mole of elephants, a mole of marbles. If I have 1 mole of whatever it is, I'm telling you that in that mole there are 6.022 times 10 to the 23rd of them, whether it be marbles or ducks or elephants or whatever it is. And that's Avogadro's number. So the number equal to the number of carbon atoms in this many grams. Now, in yesterday's lecture, we talked about this. Let me grab my pen here. We talked about this information off of the periodic table, and we said 1 carbon atom has the mass of 12.01 atomic mass units. This is now telling us that if I have 1 mole of carbon atoms, just what this would be, 1 mole of carbon atoms is going to equal 12.01 grams. And of course, it's a whole lot easier for us to measure grams. We can't really measure atomic mass units. We had that conversion factor yesterday showing you how little of a gram that an atomic mass unit actually is. So we're going to look at this in 2 different ways. If I want to know the mass of a carbon atom, it's 12.01 AMUs. If I want to look at how many moles of carbon atoms, 1 mole of carbon atoms, or 6.022 times 10 to the 23rd carbon atoms, it's going to weigh 12.01 grams. We get that information off the periodic table. So here we have 1 mole of carbon is the same thing as saying 6.022 times 10 to the 23rd carbon atoms, and that's going to weigh 12.01 grams. So there's a lot of different conversion factors we can take away from this because these are all equivalent. So I can say 1 mole over Avogadro's number of atoms, or flip that. I can say Avogadro's number over 12.01 grams, or flip that. Or I could say 1 mole of carbon is 12.01 grams, or flip that. A lot of different sets of equivalents that we can get out of this information, or this set of information from the periodic table now. A sample of an element with a mass equal to that element's average atomic mass in grams contains 1 mole of atoms. So for aluminum, if I have a mole of aluminum, which is 6.022 times 10 to the 23rd atoms, it's going to weigh 26.98 grams. And again, that came from the periodic table. Look at the difference between the mass of gold and the mass of aluminum. If you notice that gold would weigh 196.97 grams for the same number of atoms as in a sample of aluminum. So 1 mole of either one of these is going to weigh much differently. So we need to always compare the number of gold to the number of aluminum, not their masses, because masses vary greatly among the elements. Look at a problem. It says determine the number of copper atoms in a 63.55 gram sample of copper. Okay, so I need to look at this and say, what information do I know? Well, when I look at the periodic table, I notice that the mass of copper is 63.55 grams. And I know that that's the same thing as 1 mole of copper atoms. And I know that in that mole of copper atoms, there's 6.022 times 10 to the 23rd atoms. So this wants to know how many copper atoms is in the sample. Well, it just stands to reason that because this is a mole of copper atoms, there would be 6.022 times 10 to the 23rd atoms of copper in that sample. Next problem says to calculate the number of iron atoms in a 4.48 mole sample of iron. And the key to this problem is to notice that it says atoms. And we know that for anything that 1 mole is going to have 6.022 times 10 to the 23rd atoms. And knowing this reference number, we can find the number of atoms in 4.48 moles of iron. So we're going to start by writing down 4.48 moles. I'll show you the example they put here. And I'm going to multiply that by the number of atoms over a mole. And the reason we do that is because we want to make sure that we cancel. Have the right pen, we can cancel the number of moles. And and that leaves us with atoms for the top. So it's 4.48 times 6.022 times 10 to the 23rd divided by 1. Now, a word to the wise when you're putting in Avogadro's number into your calculator, and we've gone over this before, but I'm going to reiterate one more time. When you're putting it in, you're going to put 6.022, then you're going to go find the button that says EE, or it may be a button that says EXP. Just depending on the type of calculator that you have, you might have to do second and then hit a different function for that. But what you're telling your calculator by doing the button that it has here and putting the button in here is you're saying it's already times 10. So your next thing is to put in 23. You don't hit the caret button. I don't want you to use that. I don't want you to then put in times 10 to the. You just type in 23 and your calculator takes care of it. And it also takes care of it in your calculator because it keeps this entire unit together. When you use your caret button, instead to do this, you end up needing to use parentheses where this doesn't need parentheses. So make sure that you're correct when you put that in the calculator like that. So we just typed in 4.48 times 6.022 EXP 23 and then hit equals, and that'll give you your answer. Let's take a look at the next question. It says a sample of 26.98 grams of aluminum has the same number of atoms as how many grams of gold? Now, if you look at the periodic table, you'll notice that 1 mole of aluminum is going to equal 26.98 grams. Okay, if this is a true statement, then it wants to know how much the gold is going to weigh for the same number of atoms. So if we're dealing with a mole of aluminum, they want to know basically how many grams a mole of gold is going to weigh. So a mole of aluminum weighs this much. If you look at your periodic table, you notice that the mass of a mole of gold is going to weigh 197 grams on average. Remember, we're going to when we do our problems, we're going to make sure that we round to the 2 places past the decimal. I understand your book example shows you just 1, but when we do that from now on, we're going to use 2 places past the decimal point. I understand these problems are going to be a little bit more difficult than what you've been used to. We're getting back into the habit of doing the math, showing your work, because without work you get no credit. It's going to take practice. We're going to do a lot of these in class. Just make sure that you have your calculator with you every day and you're ready to go.